Q&A sessions, all on the topic of fleet electrification and the challenges and opportunities associated with electrifying fleets. So a big welcome to everyone on the call. This session is being recorded and will be available to share and view online afterwards. But if you're having any tech difficulties, please make sure you're logged in via Google Chrome. But if you have any problems at all, just try logging out and rejoining the session. So for today's session, we will be joined by some experts working in the field. Our panel consists of Claire Thompson-Sage, Sustainable Development Coordinator at UPS. We have Adam Cundy, Project Manager at Moixa, Pentelis Stefas, Assets and Technology Engineer at UK Power Network Services, and also Safinat Ataru, Project Manager at Cross River Partnership. We also have Dave Abrell from CRP, who will be facilitating the chat function to the right of your screens today as well. So during today's session, we will cover all of the topics on this slide, hearing from all of our speakers about the FLES programme and partnership working on the project, which work towards demonstrating how smart charging can incentivise large fleet operators to go electric, which is extremely topical, it being the week of COP26 kicking off. But if you have anything you'd like to ask our speakers as we hear from them, then please type the questions into the chat box on the right with your name and organisation. And if we don't have enough time to answer these, we will respond to everything via our detailed follow-up email tomorrow. So it gives me great pleasure to introduce Safinat Ataru from Cross River Partnership to start us off with an overview of the FLES programme. So over to you, Safinat.
Thank you, Rachel. Very quickly, hello everyone. I know we have a lot to get through in the next 43 minutes or so I'll try to be brief. I'm Safinat Ataru, Project Manager here at Cross River Partnership, and I'll be giving you an overview of the work we've done throughout the years with electric vehicles and related infrastructure. So, before I do so, I'd like to tell you a bit about Cross River Partnership. CRP is a public-private partnership comprised of local authorities, business improvement districts, landowners, and strategic partners. For 27 years, we've collaborated on projects that aim to make London a better place for the people who live, work, and visit here. Our vision is to deliver projects that empower people and create great places throughout London and beyond. Many thanks to the funders who make what we do possible, including the Department for Environment, Food and Rural Affairs, DEFRA, the Mayor's Air Quality Fund, and the Industrial Strategy Challenge Fund from UK Research and Innovation and Innovate UK. The projects that you see on your screen aim to support London's recovery from the pandemic. We look at improved lighting, we tackle transport issues related to air quality, freight and logistics, and of course, electric vehicles. Before I talk about our work with EVs, I would like to draw your attention to the Central London Sub-Regional Transport Partnership, which I know is a mouthful. You'll see a little picture on the lower left of your screen. The partnership is a collaboration between partner boards on transport priorities. Over the years, we've shared reports that address issues such as cycle logistics, the network capability for EV freight at various boroughs depots, and also guidance on delivering the Mayor of London's Vision Zero. So today, we're pleased to announce that the EV Rapid Charging Hubs guidance is available. It provides useful information for local authorities and landowners that includes charger hub locations and projected demand, legislation, and a case study of the Rapid Charging Hub at Glasyard in Woolwich. I believe that a link to the full document will be made available in the chat. So, on to our work with EVs over the past decade or so. We've done a lot of work involving the adoption of electric vehicles by municipalities, related infrastructure, and exploring various scenarios for their use. As you can see in the timeline, our first projects were the electric vehicles in urban Europe, EVU 1 and 2 projects. From URBACT is a European exchange and learning program that promotes sustainable urban development. The next project the orange one, Freeview, or Freight Electric Vehicles in urban Europe, took things a step further by focusing on transitioning to electric vans for commercial use. UPS, who is here today, was also involved in that project. Last mile logistics, well, it's in the title. We looked at optimizing the last mile in the delivery chain. Freight Tales took a more holistic approach to cleaner, greener freight deliveries in an urban setting. The partners shared lessons, best practices, and used each other as sounding boards for the different ideas that they tried out. More recently, we have the Smart Electric Urban Logistics Project, or SOL, which was about managing the power supply at UPS's Camden Depot, which had 20 fully electric delivery trucks. The project's outputs were shared with other fleet operators so that they could apply the knowledge gained to their fleet management. Which brings me to the EV fleet-centered local energy system, or EFLIS. It builds on SOL, but what EFLIS does is it helps to unlock the challenges of electrifying vehicle fleets through an integrated smart charging and energy resource management platform called GridShare from Moixa. And we're pleased to have Moixa, UPS, and UK Power Network Services here today to talk about the project in detail, as well as how it feeds into their overall schemes. So that's it from me. I've tried to keep it super short, but I'll be glad to take on any questions that you might have for now. Thank you.
Brilliant. Thank you so much, Safina. We've had a few pre-submitted questions, which I think, I've got time to ask you now. So EVs at COP26 are said to have kind of been hampered by the lack of charging points. There's a quote from Adam Bond, CEO of AFC Energy, stating that far more investment and coordinated planning is required to make sure we have the kind of right infrastructure in place to support the transition to EVs. So I'm just wondering what you would say is the main action required from the industry to ensure the correct infrastructure is in place for delivering the UK's commitment to reach net zero emissions by 2050.
Okay, thanks, Rachel. It's an interesting question because in a way I kind of feel like the quote from Adam Bond kind of answers it, in that in terms of what's needed as far as infrastructure and financing, I feel like I feel like the pieces are there, but it's a bit like a jigsaw puzzle, as in it's not a cohesive whole. Yes, we're addressing emissions. Yes, we are looking at barriers such as a lack of sort of an overall strategy, a restricted network capacity, and also a limited supply of EVs. And yet there are policies in place to address those things, and I feel like it's more a matter of there needing to be more cohesion, really, just pulling everything under a single umbrella and communicating it clearly. So in terms of cooperating with technology, with finance, with policy, really pulling it into a nice cohesive whole so that people know where to turn rather than being barraged by information coming from different directions.
Brilliant, thanks, Safina. And secondly, I've got another question about how EVSE addresses the following principles of electromobility. So we have slow charging to preserve battery life and avoid straining the DSO, private and commercial sharing or joint access, monitoring any energy consumption, keeping battery charged between 20% and 80%, and mobility as a service. I don't know if you have any comments on that one.
I kind of do, but I'm actually going to hold off a little bit on this because I know that when the partners go into detail with their parts of the presentation, they're going to touch on all of these, and I'd rather it comes out as a sort of a coherent presentation rather than me preempting anyone. So what I'll do is I'll let the partners go ahead and speak, and then if the person who asked the question is on the call and has further questions, I'll be glad to try and address them at the end of the presentation.
Okay, thanks very much, Spinat, and for your presentation as well. Great. So next, let's move on to Claire Thompson-Sage for an overview of UPS's sustainability goals and how they're achieving these. So over to you, Claire.
Thanks, Rachel. Good afternoon, everyone. So just to set the scene, earlier this year, UPS announced their latest sustainability goals. And we have stated that we're going to achieve carbon neutrality by 2050. By 2025, we want 25% renewable electricity in facilities. In the UK and most of Europe, we're ahead of that. So the UK, we're already at 100%. And that's very important to us for having sustainable and renewable energy to power our electric fleets. We've also committed to 40% of alternative fuel in all ground operations. Also, by 2035, we're looking for a 50% reduction in CO2 in our small package business. So a big part of those goals, achieving them, is for us to be able to electrify the fleets. There are big parts of that happening in Asia, but how we do it in Europe and the North America are very much linked. So, as I say, we've already on 100% renewable electricity, that's in place. We have an existing fleet of electric and hybrid range extended electric vehicles in the UK. And UPS is committed to purchase 10,000 vehicles for Europe and North America in the next 5 years. So we have a strategy of rollout of electric vehicles. We have a plan for the UK and also the rest of Europe. And very much what we're looking to do now is to plan the infrastructure we need to support those vehicles in each of our facilities. And that's a big part of the cost of electrifying the fleet. So as Stefanat mentioned earlier, we've embarked on the SOL project initially, and this helps us avoid a large capital investment in electrical infrastructure for a grid upgrade by employing smart technology. The EVSE project is moving on from that. So we've worked with Cross River Partnership, Moixa and UK Power Network Services. So whereas SOL was more about the capital cost of electrical infrastructure, EVSE builds on that and really looks to how we can optimise electrical usage and operating costs. So this is the second phase of the Smart Grid project. And we're hoping that this will again further bring down the costs and the barriers and challenges to electrification of fleets. So I'll answer any questions before we move on with Moixa to explain exactly how they've been achieving this.
Thank you, Claire. Perfect. I've got a few pre-submitted questions as well. So how much kind of driver awareness or familiarisation do you as UPS adopters of EVs kind of provide for those drivers, and what would you say to other organisations looking to educate their drivers on EVs?
So that's been a mixture up until now. We've had the majority of the electric vehicles we have in the fleet have been retrofits of diesel vehicles. So the layout of the vehicle is very similar. They're essentially driving the same body vehicle. Obviously, we have the electric dashboard and the training that the drivers go through. I'd say one of the biggest things that we've had to really concentrate on is making the drivers aware of how much quieter they are. I mean, they can tell themselves, but it's really from a safety aspect, being more aware than they are already of the safety aspects for pedestrians, and that the vehicles are pretty much silent. The bigger training part has been we've had to train our automotive mechanics to service and maintain the vehicles, and also it's mainly our sorters who are plugging in, putting the vehicles on charge, understanding the alert systems and the dashboard that we have to ensure all vehicles are charging at the correct rate, as well as charging and resetting those charge points.
Perfect, thank you. And the next question we've had through is, would UPS see kind of booking a parking or loading bay that has a rapid or fast charger as a benefit for operations, kind of allowing drivers a guaranteed space to take breaks, whilst also extending the vehicle range and the amount of parcels delivered?
Yeah, this is a really good point. I mean, at the moment, we've concentrated the vehicles we have predominantly in London, but also in Southampton and Birmingham, because of the issue of range. So our initial rollout of the arrival vehicles will be in a lot of the major cities, which generally have denser routes and do less mileage. But certainly, as we go towards net zero and we want to electrify the whole fleet, we're going to get to a point where we have vehicles doing routes which are above the range for an electric vehicle to just be charged overnight. And time is money when you've got drivers delivering. We can't have drivers driving round or queuing for electric charge points. So I do think either we will be looking at there'll be areas developed for fleets to charge from, or it will be a booking service. So I can definitely see that that's going to be something that would be useful and maybe even necessary to enable fleets to operate in more suburban and rural areas.
Brilliant, Claire, thank you. Yes, if there's any more questions, just put those in the chat box and we can come back to them. Thank you, Claire. Next, we're going to be hearing from Adam Cundy from Moixa, who will be presenting on the GridShare platform and fleet electrification. So over to you, Adam.
Thank you. Hi, everyone. My name's Adam Cundy, and I'm a project manager here at Moixa. I'm going to be talking through, firstly, who is Moixa? Second, what is GridShare? And third, how is GridShare being applied to the fleet electrification problem, focused on what we're doing at EVSE. So firstly, our vision and purpose. We believe by increasing the IQ of batteries, Moixa can help build a future powered by renewables. So I think that will make more sense once I speak through where we've come from. So Moixa first started out developing domestic ESS for maximizing solar consumption, and then alongside that, we developed artificial intelligence and predicting software to help with this. So that's really where GridShare was born. That's the birth of the algorithm. By predicting a household load and the solar production, and understanding what tariff that particular site is on, whether it is a cheap price period at night or a dynamic tariff, we can feed all this information into GridShare, and it will work out the optimal usage of the battery for the cheapest energy bill for the site. So that's where it started. We built on top of this energy aggregation and virtual power plant capabilities. So by tying a bunch of sites together, we can use them in grid services such as constraint programs or national services of those sorts. So that's GridShare. For managing those fleets of assets, we have a platform called GridShare Partner. So it looks across large fleets. We currently have the largest virtual power plant in the world, I believe, in Japan, with 20,000 sites under control. And then we have, I think, 30,000 in total and 300 megawatt hours total capacity. So GridShare was firstly based on energy storage systems. We've now expanded it out to use to control EV charging as well. So primarily in the domestic space, if you add an electric vehicle to that equation, there's certain constraints around when the vehicle must be charged to certain levels. GridShare takes that into account and can optimize the charging of the vehicle as well. So that's GridShare. Next, I'll talk about how it's being applied to the fleet electrification situation and the EVSE project in particular. So the challenges is well known. There's an increased consumption when you electrify your fleet, and there is a limit on how much power you can use at any particular time for the site. And upgrades to that are extremely expensive. And so if you think about the depot use case for UPS, they have a lot of power being used at night when all the vehicles are in the depot being charged, and then very little during the day when they're out delivering and there is only the base load for the site. So the current solution is to monitor the consumption at the site and shift load or schedule out the charging of those vehicles to make sure you're keeping it under the total consumption for the site. So I've got a diagram here on the site to give some visual aid to this. At the moment, we've just got a grid connection, the fleet load and the depot load, and this will change as I go through the next slides. So that's the current solution. What is GridShare adding on top of this? So the further opportunity is these 4 dot points I've got here, and I'll go through each of them in more detail in the next lot of slides. So firstly, optimizing for cost. Second, incorporating other distributed energy resources. Third, private wire public charging. And fourth, unlocking flexibility revenue services. So firstly, optimization for cost. We already spoke about what's needed just to operate under the constraints, but let's talk about what's needed and what can be done on top of that. So first piece of that puzzle is state of charge of the vehicles. By knowing the state of charge of the vehicles, and we can have greater flexibility in when we charge which vehicle in the overall scheduling algorithm. There's a number of ways you can get state of charge through the chargers, if they're DC, through various communication protocols, some coming out in the future. But in this case, we're getting it through integration with a telematics service through an API. The second part of the equation is the time of use tariff, so the price of electricity at any time on the site. So it might just be a simple day-night tariff where you have a cheaper period during the night, or it could be something quite dynamic like an agile tariff where you have prices changing throughout the whole day. So GridShare will take into account the state of charge of vehicles and the load required and predict out this load. It can also take into account the price of electricity, and the main thing it will be doing here is trying to load shift as much of that power it can to the cheapest price period, whilst still maintaining the vehicles are all charged by the time that they're needed, and the total site capacity available at any time is not exceeded. So that's the first and biggest part that GridShare is bringing to this solution, is this optimization for cost point. Next, we have incorporating distributed energy resources, primarily solar and energy storage. So if we had on site behind the meter energy storage and solar, how would that what would that add to this overall optimization? So the first and most obvious piece would be to maximize self-consumption. You would be using solar for depot load and electric vehicles when available, but when they're not, you can be charging the battery and load shifting from high price periods to low price periods. You can also be using the energy storage system to assist in flexibility services that demand perhaps a more immediate response or some other characteristic that electric vehicles can't fully handle. And I'll talk about that a little bit more in a future slide. So GridShare can take all of these aspects, these distributed energy resources, into account in its algorithm and use them to aid the optimization calculation to minimize the energy bill for the site. The next one is private wire public charging. So in front of the meter, well, it's actually behind the meter, I should say, that you're providing a public charging service. So you have a lot of spare capacity during the day with the nature of a depot that it's charging overnight. You can share that power with public chargers. You could also use the solar power during the day to provide the public chargers. And you could also, it also brings about a new constraint in that you might not have as much power available for charging electric vehicles and the depot usage, and you would need to take that into account as an added constraint on the optimization problem, and that is something that GridShare can do. The last part, so we've talked about the optimization of the site and what can be brought in to maximize that. Now we talk about what can be done to add a new revenue stream in flexibility services. So so now GridShare basically has in its hands a forecasted and flexible load profile. It's able to tap into the services through CloudLink and API integration. And this enables it to participate in programs like local constraint programs through KPNS perhaps, and national programs, balancing services for national grid. So GridShare, we already do this with domestic batteries. This would be expanding that capability to forecast and bid flexible capacity, and is also on top of that able to optimize the dispatches. So understanding which vans could be turned off at which times without exceeding any of the known constraints. So that's my presentation on GridShare and EVSE. Do we have any questions?
Fantastic. Thank you, Adam. We've had a few questions in the chat. Firstly, from Rob Edwards. At a typical site, how much electricity are you able to self-generate?
Obviously depends greatly on how large a solar array you can fit on the site. I don't think I can give any exact numbers to hand. I could possibly share some numbers from the EVSE project, but I don't have them on hand currently. But basically, yeah, you fit as many solar panels you can on the roof, but it's not always that simple. You need to look at how, in what way that power could be used in cooperation with what charging you have on site, the scheduling of that charging, and any other energy storage systems or other uses for that generation.
Great, thank you. And secondly, from Justin Laney, how much energy is generated by the PVs and how much is stored on site?
So at the moment, this is it's all hypothetical. So we're basically running simulations. We're simulating solar production to see, simulating a range of different sizes of solar production to look at how it could aid the energy optimization problem. So we don't have any solar panels on the Camden site currently. This project is helping to inform what the worth of those panels being installed would bring.
I'll move on to a pre-submitted question as well. What scale of contribution do you think smart charging of EVs can make to the energy cost and supply issues that some are predicting for this winter?
Okay, so I would firstly say that uncontrolled charging is obviously going to negatively impact energy cost and supply issues. If we're bringing on a lot of charging at the already strained peak times of the day, it's obviously going to make things worse. What's really needed here to limit this is smart charging. So in the domestic setting, I think smart charging is a term used loosely, but I think scheduled charging is pretty ingrained. But as we bring on more electric vehicles in various settings, a big piece of this is going to be scheduling that charging or load shifting to the less constrained times on the grid. And this is going to be a big piece of the puzzle, as well as expanding the generation required as we move towards a fully electrified transport industry well into the future.
Perfect, thank you. And we'll take one more from Simon Farrow. Can you link a number of depots together to form a wider overall benefit?
Yes, definitely. I'm surprised I didn't mention that actually, focusing just on one depot in this case. Yes, definitely a future use case would be basically producing a virtual power plant of a number of depots, and that would only bolster the capabilities of delivering into flexibility services. So one such use case for that could be bidding into balancing mechanism. If you had a number of sites together, it would be a lot easier to reach like the minimum capacity requirements for services such as that, and would give you a lot more flexibility in how you deliver that service across multiple sites. And that's something that GridShare already takes into account when participating in services using a number of domestic sites. I hope that answers the question. Rachel, I can see you on my screen. You might be on mute currently.
Sorry, my connection's just gone a bit... my connection's gone a bit funny, but thank you so much, Adam, for your presentation. I hope you can hear me. Sorry if I cut you off. Okay, thanks, Adam. Last but not least, I'd like to invite Pantelis Stepas to the discussion to talk about UK Power Network Services and their involvement in the FLES programme as well. So over to you, Pantelis.
Yeah, thank you, Rachel. Hello, everyone. Hi, my name is Pantelis Stepas, Assets and Technology Engineer working for UK Power Network Services. And today I'll talk about how UKPN services can support fleet owners to transition to the EV technology. So firstly, I will start by giving you some background of who we are, what we do. So UKPN services are the commercial arm of UK Power Networks, the electricity distributor of South East England. So we are experts in distributed energy solutions and power distribution, and we support our clients through the full life cycle of project delivery, starting from consulting, design, build, capital finance, operation and maintenance. Our client portfolio include some of the highest profile public and private sector organizations across different sectors, including aviation, railway, utilities, defense, fleets, public sector, and ports. And just to mention some of our client names, we work closely with Heathrow Airport, Stansted Airport, Gatwick Airport, HS1, the Ministry of Defense, and UPS. In terms of our solution offering in the EV technology, we support our clients to transition to the EV technology, and we are experts in optimizing your existing assets and integrate EV technology. We offer end-to-end solutions starting from feasibility studies to design, build, and operation maintenance. Importantly, we are technology agnostic, and we ensure that we always design a future-proof solution that best meets our clients' requirements. and we can also offer capital finance if needed. Having this in mind, in the following slides, I would like to take the opportunity to explain how we have worked with UPS over the past few years to support their journey in transitioning to the EV technology. So the journey for UPS started a few years ago when they wanted to operate the first 42 EVs out from the Camden Center. So back then, UPS upgraded their network capacity and installed the required number of charge points. Based on this setup, the UPS was able to accommodate up to 63 electric vans. Following this, UPS's ambition was to electrify the entire fleet, and we wanted to operate 170 vehicles. So we worked together through an innovation grant with CRP and UPS to develop a smart charging system, which, as Claire described, was designed to avoid potentially costly and disruptive infrastructure. And also, we managed to defer any connection upgrades. So the way that this smart charging solution works is that we monitor on a real-time basis the on-site demand, and we manage the EV fleet and the on-site storage to ensure that we won't exceed the maximum capacity agreement. And that brings me to the EVSE project. This is the third phase of the EV journey for UPS. And the main driver for this project is to accelerate the rate of fleet electrification by capturing new opportunities for cost reduction and revenue generation. So as Adam described in detail, we are currently developing the next generation of smart system, which will be able to optimize different kind of assets on site, including the fleet charging, the battery storage, on-site generation, and any spare connection capacity. And through this system, we will be able to add value through the optimization of the EV charging. We are also exploring opportunities to share infrastructure with publicly accessible charge points. And we can also deliver flexibility to support the electricity grid and also unlock new revenue streams. As you can understand, the benefits arising from this project are numerous, and that include benefits to the fleet operators, such as optimized costs, savings, and revenues. We can ensure acceleration of the electrification of the commercial fleets. We also support the local and national electricity network by providing flexibility. And also, we can support the wider EV take-up by improving access to rapid chargers. And also, there's an impact on the society, since we contribute to the overall reduction of the CO2 emissions and the improvement of the air quality in central London. In terms of the future, we strongly believe that there's a huge potential for UPS and through this EVSE project, but apologies, not only for UPS, but also for other fleet operators. More specifically, we can implement the same approach to other UPS sites and other customers and help them to maximize utilization, savings, revenues, and also reduce their costs. In addition, the same smart system can also be applied to other applications such as charging hubs, and charge point operators can maximize their savings and reduce the costs. While we have also identified areas of development, including new charging technologies such as robotic arms, wireless charging, V2G, which can add further value to the fleet operators. And also, we have also identified opportunities to explore private wire connections to adjacent businesses and offsite generation, which can further reduce costs for fleet operators. I think that's everything that I have prepared for today. I will welcome any questions. Thank you.
Thank you, Pantelis. We have a question from Rob Edwards. Is there a way of working out roughly what the payback period is on the original investment?
That's an interesting question. To be fair, I think, as I mentioned, this is an innovation project which is funded by Innovate UK. So at the moment, we are just developing this smart charging solution. We have a commercialization strategy, but at the moment, it's not commercially available, so we can't really know how much will be the payback time. However, our analysis have shown that we're able to achieve up to 40% cost reduction to fleet operators based on the UPS cabin use case.
Brilliant, thank you. And a few pre-submitted questions. What can the UK government do to accelerate electrification across all transport and logistics systems?
Yeah, I think that's an interesting question. I'm not a policy expert, so I'll try to answer this from my point of view. I think the UK government, it's clear it has a commitment to transition to zero-emission cars and vans. So I think in light of that, there are different financial incentives to support the early adopters, such as like grants and tax benefits. So I think it's important for the UK government to continue to offer this in the longer term. And I think the other thing is that, as I mentioned, EVSE project is funded by Innovate UK. So I think it's also important for the government to ensure that there's available fund for innovation projects to support new products and new services, which will accelerate the take-up of EVs. One thing that I think is important is for the UK government to ensure that there is a strong supply chain for EVs and other parts of the EV infrastructure to support the increasing demand of the EVs in the following years. I think that's something that I'm not sure if there's a clear strategy at this stage.
Brilliant, thank you. And we'll go for one more. What would you consider the main push and pull factors for a business changing their fleet to EV?
I think the main push factors that have forced businesses to change their fleet to EVs, I think, are horizontally integrated policies from the government, such as the ban of the internal combustion engines vehicles by 2030, as well as the wider UK CO2 emission targets to reduce reduction targets. So this has forced the fleet operators to transition to the EVs. However, I think there are key factors that have pulled fleet operators to the early adoption in EVs, and I think it's clear that the economic benefits from the EV technology are evident, since there's a significant reduction of operational costs and reduction in the fuel costs. And also, I think there are other non-tangible benefits, such as reputational benefits and corporate social responsibility for large organizations.
Brilliant. Thank you so much, Pantelis. And a huge thank you to all of our 4 speakers. I hope you found their presentations insightful and they provided you with further knowledge on fleet electrification today. All the unanswered questions will be followed up with outside of this session. So yeah, we will be posting those tomorrow, and definitely have a look at the links that have been in the chat this afternoon as well. Our next Lunchtime Launch session will be the Good Parts for London 2021 report launch, looking at parts and climate change with Parts for London, GL Hearn, and the Black Environment Network in a few weeks' time on the 18th of November. We hope to see you there. There is a link to sign up in the chat now. But if you have any queries at all, don't hesitate to get in contact with one of us on the screen. Our contact details are there. Yeah, I'd like to thank all our speakers today and for everyone for tuning in and participating. And we will see you again soon. Thank you.
Thanks, everyone.
Thank you.
Thank you.